Do you edit all those videos and then put them on, or do you just
post them. Takes so much time, no one cares. Okay. Alright. So, section 0.2, that's the section we're in. Yesterday, we talked about the algebraic expressions, right? That was kind of some of the vocab we've discussed yesterday. There's a rhyme and reason why we did that. Because obviously when we're going into these sections about algebra, the number one thing people get really stressed out about is not only just the math involved, but you don't understand the words I'm using, the vocabulary terms. When you're reading, an instruction in a textbook, it can be confusing where you're trying to figure out, what is that problem even asking for? Like, you don't understand the keywords there. So that's why we went through that yesterday. I want to review that one more time so you get a chance to kind of look over some of those words. I'm not going to have all the words on the board. We did that yesterday. I think, did everyone get the email from me yesterday with that document? Sent out the document that had the little file that I think we typed out yesterday? Yeah. So, okay. So it should have, if you haven't checked your email, I sent out an email, had the actual file that had all those keywords in it. Email it to everyone. So check your actual email, or maybe it shouldn't go to junk because it's from a teacher. But it was on that email that I attached that said we had homework due today. So it was on the bottom. Okay. All right. So algebraic expressions. Let's go through this. So here's my outline today. So I want to do a quick review of verbal expressions. Those keywords we talked about yesterday, because we're going to need those. We're going to actually use those today a little bit. Okay. Next thing. Obviously the vocab that goes with those expressions, I want to review that. Now we're not going to go in depth as far as I want. It's just to glaze the surface because you're going to see what we're going to talk about today, how these actually fit. Okay, new things that we're going to cover today, brand new, that we have not discussed in here anyway, is we're going to talk about the classifications of real numbers. So that means when we start talking about digits, certain numbers fit in certain categories so that when we start doing certain types of math, you understand what type of math we're supposed to be doing with that problem. Okay? So let's start with the algebraic expressions. Let's start with these. These are the ones we did yesterday. So just quickly going through this. So these are verbal expressions. It's how we write things out in word form. So when we talk about, like addition, we're adding. What were some of the keywords you guys remember from yesterday? What were some keywords that also mean adding?
Sum of.
Sum up, that's good, that's one of the main ones. What else?
Where's my hand?
Oh yeah.
Subtraction?
No, not subtraction, just for addition.
Oh.
Just for addition only. We have sum up, what's another word that you know for addition?
Add to.
Add to, there's a good one. Another keyword, starts with
Plus.
Plus, easiest ones in the world, right? So here you go. So these are just some of them, right? Added to, plus, more than, increased by. So we have a lot of different ones we can use, etc., etc., etc. Again, I sent out that document yesterday, so you can actually kind of read through that. Now, let's talk about subtraction now. What were some keywords for subtraction? Keywords when you're going to subtract numbers. Any ideas?
Minus.
Minus, that's a good one, right? That's probably the number one people always want to use. Let's go with 7 minus 12, right?
Subtracted by.
Subtracted by, there's another good one. One more.
decreased by?
Decreased by, boom. Look at that. Here's a list. I even put the ones with stars next to it because I know when we typed that out yesterday, I did have a couple that I wanted you to star because they're special cases. So there you go. So minus, subtracted by, less than, subtracted from, decreased by, etc., etc., etc. There's more and more and more. Okay, let's go to multiplication now. What do we got for multiplication? Product of. That's a good one. Product of is the number one that people tend to forget. We're going to use that one today. We're going to look at that. What else? I want maybe one more.
Oh, times.
Times. The easiest one in the world. Yep, times. There you go. So there's your smaller list. Now, obviously, there was a couple special cases I threw in yesterday, like twice or triple. Those were some of the special cases of multiplication we discussed. And now division. Division. We'll go for 2 again. There are keywords for division.
Divide.
Divide. Okay, there's number one. Divided by. One more.
Half.
Half. Okay, that's a very specific type. There you go. Wow. Sorry. Losing my voice here. All right, so we got divided by, quotient of, ratio of, half, very specific examples of verbal expressions. Now, I know this seems weird. Like, it's a weird topic to kind of like bring up in the beginning of the year, but here's the thing. When we start talking about numbers, add, subtract, multiply, and divide, and I start using keywords, like, let's talk about the ratio of these two numbers, right? Ratio is division. It's how you divide them. Maybe you're not proficient at dividing, or you don't know how to divide in your head, but you at least understand what that word means. Oh, we're gonna go try to break down numbers, into smaller parts, right? Kind of like factors. Factors are parts, they're pieces of a product when you multiply numbers together. So it's one of those things, it's nice to get that vocabulary out of the way, so when I start using words, you at least are familiar with them. You maybe don't have them all memorized, but you at least know. We're gonna come back to this. This is not going away. This is every section kind of a thing where I wanted to bring this up because they're gonna use it. The textbook will constantly have these in the instructions. Okay. Questions at all about our first topic here? Okay, hopefully you feel a little bit better about it. We will get to more in depth with this. This is just kind of the intro. So don't feel like we're gonna do crazy amounts of it right now. All right, let's talk about the new thing today. Brand new stuff. I wanna talk about the real numbers. Real numbers are classifications of numbers that you've learned over the years of math, starting in preschool, kindergarten, all the way up to today. And you don't even realize it. You learned it very, very specifically in order so that it will make sense to you, okay? And so there's this weird strategy that they've come up with to actually introduce numbers so that by the point you get to high school, you kind of know how they fit together. Maybe not perfectly, some people still don't like fractions or decimals, but you get the idea of what they are, okay? So the goal today is to introduce these classifications. There is, I believe, 5 classifications, 5, that we're going to go through today. And so the goal today is, before you leave, is that I'm going to give you kind of an exit ticket today, where I'm going to give you a couple problems on the board, and I'm going to see if you can figure out, when I put that number on the board, what category should it be in? What category was it supposed to first fall into? Okay, so this is where you really have to pay attention to what these numbers are, the numbers that fall into these places, okay? All right, I'll start with the first one. So the different classification. This is the first classification of a real number. Real number is a group of numbers you've learned. The first one is the ones you learned in kindergarten. So think about this. What were the first numbers you remember learning?
1, 2, 3, 4, 5.
Exactly right, you nailed it. You start with 1, you go 2, 3, 4, and you go and so on and so forth, right? That actually has a name. It's called the natural numbers. They're naturally the numbers you start with. Okay? 1, 2, 3, blah, 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 blah. Notice, did you start with decimals in kindergarten? No, there's no way.
That was about 4th grade.
Yeah, 4th, 5th grade, somewhere in that ballpark when you start learning how to add, subtract, you understand the concept of what a decimal is, right? But the idea is that they start in kindergarten with 1, 2, 3, 4. Notice, there's no 0. Little kids don't understand the concept of 0. To give you a kind of a weird example, if you had like a really small child, like a 4-year-old, 5-year-old, and they had a piece of candy, and you took the candy away from them, what would happen?
Cry.
Yeah, they're gonna lose their crap, right? They're gonna start crying, they're gonna start screaming, because they don't understand what 0 means. They honestly don't. Their brain can't even comprehend. Because like a high schooler, if you took candy away, they just get mad, but they just sit there and go, okay, I'll get another piece later, or I'll take it back later. Because you understand the concept, like, it's not the end-all be-all. You know you can get more later. A 4-year-old doesn't understand that. When it's gone, right? So they don't understand 0 yet. They don't understand it can be added to later. So natural numbers, you start with 1, you move up. And this goes until you can't count anymore. I think by the end of 1st grade, they want you up to the hundreds or something like that. There's some category that they want you to
Well,
go.
like in 2nd grade, we did that chart with Mrs. Schmaby.
How far did you have to go?
Like 1,000.
Oh, great. I didn't realize it go that far. Okay, so you guys get the idea, right? All right, let's go to the next category. Next category that you get in about probably 2nd grade, 1st grade, you're gonna get whole numbers. Now, here's the weird part. The whole numbers is still the natural numbers. They're still the numbers you learned in kindergarten. 1, 2, 3. They added one more number. What number do you think they added? 0. How I remember whole numbers, it literally has an O in its name, and the O looks like a 0. That's how I remember that category. So it's adding one more number. But because by the time you get to 2nd and 3rd grade, your brain can comprehend what 0 means. You run out of something. You can get more later. You don't have that mental breakdown where you can't handle that anymore. So that's a whole number. So 0, 1, 2, 3, 4. Notice, no decimals yet. Now, the hard part is in 2nd, 3rd grade, and 4th grade, and so on and so forth. Now they start teaching you how to deal with 0. How do you add 0? How do you subtract 0? How do you multiply by it? And how do you divide by it? Which you can't, but you get the idea. They start talking about that concept when you get older. All right, questions with the first 2 categories. Now, do you agree that natural numbers and whole numbers are nearly the exact same category?
Yeah.
It's one number off. So if you give me a number between, 1 and 100, you could technically call it's a whole number and it's a natural number. It fits in both categories. They're in the same. They just added one more number. Okay. All right. Next classification. This will be the last one before I test you whether you can remember these categories. The next category is called the integers. These are the ones you hopefully learned in 3rd and 4th, 5th grade. These are the ones that at first are the new problem in math. They're the ones that you hate probably the most up to this point. If you looked at those last previous lists, we did 1, 2, 3, 4. We added 0. What are the new numbers we're going to add to this category? Go past 0.
Negative.
Negatives. They're the number one thing people hate. 3rd, 4th, 5th grade, you start learning how to add negatives, subtract, multiply, divide by them. It's a new thing you hate in math. You're like, I can't figure it out. I can't figure out the negative signs cancel if they stick around. You start learning all these little strategies. But negatives make sense. Now, to think about this, natural numbers were introduced by the Egyptians with hieroglyphics, right? They're just numbers, they created a symbol that represents a number that, represents a token. 0, also represented by the Greeks, when they could run out of something. They understand the concept of 0 having 0 of something. Integers, introduced by the Israelites, because during biblical time, the integers were actually used for debt. If you owe money to somebody, you're negative in the hole. You owe money. You can be like in your bank accounts today. You can go into the negatives when you overspend. You have an overdraft, right? An integer is still used. That little negative sign is just a little visual marker to make sure that you understand you are below 0. You owe money to get up. It's just a visual representation of it. So that's an integer. Notice, no decimals yet. They'll eventually get to the decimal, 5th, 6th, 7th grade. But integers are the new thing. I think I remember learning integers 3rd, 4th grade, somewhere in that ballpark, when you started actually learning how to work with them. Okay, questions with the 3 categories, the 3 main ones so far, out of the 5. Okay, let's test whether you can remember this. So you don't need anything, you don't need to put any paper, you can just kind of watch. I just want you to get a sense for this. So I'll ask for maybe a group, a little pod to raise your hand. Okay, so here we go. Or if it's not what is it doing? My computer's about to crash. What's it doing?
How do you think I'm here?
Freeze it? I did go and mess it up. What did I do? It's not me, it's the projector. This thing's literally off. I knew.
What do you mean?
No, this is brand new. I spent a ton of time. Okay, here we go.
What do you mean you're not?
Okay, alright, here's my example. So, all I want you to do, think about this out loud, you don't need to write down anything. If you want to write down the examples, you can. Alright, so here's the idea. I'm going to give you a number on the board. This is kind of what our last, exit ticket will be like. I'm going to give you a number on the board, and I want you to think about what category does it fit into, right? What classification? So, I'll give you the answers here in a minute, so you get a sense. So, the number will be on this side, the answer will be over here. Now, when we do the exit ticket, I won't provide these. I'll just give you these, and I want to see what you know. Okay, but we only have 3 categories. What are my 3 categories currently?
Natural numbers, whole numbers, integers.
Boom. Natural, whole, integers. Those are the only 3 categories you can pick from. So, first number we have. -4.
Integers.
Integers, right? Integers are negatives. Now, it doesn't fit the other 2 categories. Negatives were the first time they introduced, so that's just integers. You get the idea now, right? I'm looking for the one category it fits into. Okay, so next one. Don't say it out loud. Sit for just a second, just kind of look it over, because I want everyone to kind of process it. So here we go, next one. Don't say it out loud. The number 51. So I want to know what classification it would fit into. Okay, somebody want to raise their hand? Somebody's got a kind of an idea what they want to do, or what category it would fit into. Don't be shy. Just fire. All right. What do we got? Please.
Natural and whole.
Okay. So, natural, whole, and what was the last one we just learned? Integers. If it's every single category. So most people will say the natural, right? Because you are right. It was the first category it fit into. But you're not wrong. It's also a whole number, because whole numbers are 0, 1, 2, 3. And it's also integers, because integers went negative and positive. They went up all the way through the spectrum. So I could see this could fit in 3 different categories. I'd prefer that you just give me the first category, but I expect that there is, all 3 of them. Okay, last example here. The number 0. Okay, fire it out there if you know.
Whole numbers.
Whole numbers. It has to be whole. It could also be an integer, but the first category it fit into was whole. Because the integers also had 0 and they had negatives. Alright, do we understand the concept? So the exercise today should be super easy. You're giving me the first category you can think of. Now some of them have more than one, like this 51, it could fit in a bunch of different categories.
So we just say the first one?
Yes, on the first one, I'm fine with that. Okay? Alright, do we feel comfortable with the number system?
Yeah.
Okay, now, obviously, these numbers are stupidly simple. They are, right? They're ridiculously easy. We haven't got to the last 2 categories. The last 2 categories, we actually will need a calculator for them. Because that's the hard part. So if you have a calculator, I would like you to take it out. If you don't, I have a couple back here you can come grab. I only have 10, so you might need like...
Sam, grab me one.
So,
Sam, grab me one.
Sam, grab me one.
Sam, grab me one.
So if you need one, go grab one.
So it's like
Back
this?
there. Yeah, I'm gonna take one out.
Oh! No. Do it, it's fun. They're out.
Everyone's got one if you wanted one? Does anyone still want a calculator? I might have one extra one. Extra. And you can share with your neighbors. Anyone else want one?
Whoa.
Come on. I'll give you one here in a minute. Hand that over. There you go. I'll give you another one. Oh. Let me go grab one. I think I got
Took it out one. Figure that out.
Who else wants a calculator? Ignore the crack in the screen.
I don't care.
You're
I don't really care.
Alright, so we're good? We got one? Okay, perfect. Alright, let's jump right in. Now we got the next category of numbers. Now I'm going to leave the lights on because some of these are solar power. You do need the lights on. Okay, alright, here we go. The next category. Alright, so next classification. Here it is. It's called a rational number. Okay, now a rational number is very specific. Okay? Now, when you look at what I'm about to give you for the classifications of rationals, it will throw you off because of the way I write it. Okay, alright, here we go. Rational numbers. Anything you can write as a fraction or a decimal. Now, I put a star next to decimal, there's special cases. But anything you can write as a fraction, anything that is a certain type of decimal, is considered a rational number. So these are like more like 5th, 6th grade, 7th, 8th grade. This becomes the new hated category of numbers, right? People hate adding fractions, multiplying, dividing, because you just don't know the rules, you don't remember them, you gotta practice it. But the idea is that this category is still a big part of the overall process. In fact, currently this one right here is the biggest category of numbers we have up through all 3 or 4 of the lists that we have so far. Now, let's talk about this. The decimals that are involved. The decimals have to be terminating, that means ending, or they have to be repeating decimals. No other decimals count. Like pi doesn't count. So pi's up here on the board.
Why didn't that count?
Because, look at the end of pi.
37?
Yeah, but it has the dot, 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 right? The et cetera, et cetera, et cetera. Pi doesn't end. And pi doesn't repeat. At no point will pi ever start back over at 141592. It never will. It's completely random. So that's why it would not fit this category. Because this category, the decimals have to end, and they have to repeat if it's not going to end. But pi doesn't. There's a mathematical formula that proves pi it never repeats. Okay, now let's talk about this. Give me an example of a fraction that we know of.
1/2.
1/2, half, right? Half's a decimal. It's a terminating decimal. Half, 1/2. On your calculator, take 1 divided by 2. Which is?
0.5.
0.5. It's a terminating decimal. It ended for sure. Now, what most people don't remember from, algebra class or general math days is that, the number half, how they actually created it is you take, so we know that these are the same you just did, we calculated 1 divided by 2. It's how many numbers are after the decimal, that's how many zeros go on the bottom. So if you have one number after the decimal, there's 1 0 on the bottom. 5/10 is the same thing as half if you simplify it. Just to prove my point, type in the number 5 in one of my calculators. Type in 5. Type in 5. Now the button you're going to look for is the A, B, C button. It's like this. I think it's kind of in the top half. When you hit that button, it's gonna add this like weird little backwards L. Then you're gonna type in 10. And when you hit enter or equal,
1.5.
gives you half. It will automatically simplify fractions for you on these things, which is really nice. You don't have to think about it. It automatically simplifies. But again, the whole process here, if you can make this a fraction or a terminating decimal, it fits in the category of rational. Now, here's the thing. We also have repeating. I'll show you that here in a second. Question.
Dude, dark not bad. Dark, do it again.
Okay, here it is. Okay, so second. Second one.
Oh, there's
Dark.
Yeah, so.
Dark.
Or maybe hit the fraction. Fraction. No, there. Shift. Simplify mine. Yeah, and then you can go over and pick one.
Let's go.
I'm just gonna laugh at you.
We're trying to.
I wouldn't know.
I'll give you a better one. I think that's a stack calculation. I'll figure it out here in a second. Why is that one different than all the rest? It has to be a stack. I'll get you different. All right. Now, hey. Anything you write as a fraction or a decimal that repeats or ends can be a rational number. Now, here's my question. The number 7. What classification does 7 fit into?
Hole in the hole.
Whole or natural or an integer. Okay, it can also be a rational number. Here's why. I can make any whole number a fraction. Because what do you have to put on the bottom? Not a 0. A 1. You put a 1. If you put a 1 on the bottom, it automatically makes this. It automatically makes that a fraction, so it is a rational number. Now to prove the point, type in 7 divided by 1 in your calculator. It just tells you 7. By dividing by 1, it makes anything a fraction. Now, let's talk about what I just said earlier. When I said earlier you had to put a 10 on the bottom, 1 0. That's because I had a decimal point. You had to look at this, it had 1 decimal point, so I had to have 1 0 on the bottom. That problem doesn't have a decimal, so I don't put these zeros on the bottom. That's the concept. Okay, so anything you write as a fraction or a decimal that ends or repeats. Repeating decimals are anything like 0.3 repeating over and over and over and over and over. How you get something like that? Take 1 divided by 3 in your calculator. 1 divided by 3. It's a repeating decimal.
3.
Yeah. It just repeats. Now, here's the thing. To make any type of repeating decimal, somebody make up a decimal that you want to repeat.
4.
Okay, so let's say 0.4. Okay? So let's say 0.4 repeating over and over and over and over and over, right? Here's the easiest way I can teach you how to make a decimal that repeats. How do you do it?
4 divided by 1.
4 divided by? Not 1.
4. I don't know.
I
Three.
tried taking 4 divided
Six.
by 4 and it says
4.
error.
9.
Take 4 divided by 9 on your calculator.
How do you know that?
0.444 repeating, right?
Got 1.
Anytime you divide by 9 on a calculator, if you want a decimal that repeats, it will automatically make a repeating decimal out of it.
No.
So if you want it to be a 0.4 repeating, you just divide by that.
Do it again. You can free.
So the trick is on this one, 3 divided by 9 will also make 0.3 repeating. That's the idea. All right, let's go to the next one. Okay, all right, next category. Last classification. The weirdest classification of all, I've even given a hint to it. It is called the irrational numbers. One of them is in the room here, above my marker board. Pi, it's right above it's in that poster there. Pi is an irrational number. It's any type of decimal that does not end and it does not repeat. Now, you're probably thinking, okay, how does that even happen? How do you know that it doesn't? There's mathematical formulas that if you can't write it as a fraction, it doesn't end and it doesn't repeat. Okay, pi cannot be written as a fraction. Okay, pi, where pi comes from, just so you know, it's taking the diameter of a circle and the circumference of a circle, that's the distance all the way around the circle, and dividing them, and it gives you pi. So it's one of those things, it works on every circle. Doesn't matter if you have a volleyball, a baseball, a basketball, like different sizes of beach ball. When you take the distance around the actual ball itself, and you divide by its diameter, the distance across from it. So the distance around that circumference. And you take the distance across, which is called diameter, and you divide these two numbers, you will always get pi every single time on a circle. If you measure it accurately. Now, obviously, we'll get close because we can't fully measure the circumference of the circle. You can do the best you can, it'll get close. Now, here's the weird part about irrational numbers. I want you to wrap your head around this. They don't end, right? They don't terminate. So this number pi keeps going forever. So there's always another digit that they're finding. But here's the weird part. It doesn't repeat. So what that means is that it has the possibility to have every single combination of numbers in it at some point. And it doesn't ever come back to 0.14159. It won't come back to that point again. So here's the weird thing. Think about it this way. Irrational numbers are so unique that your personal cell phone number is in there perfectly. 1641, blah, 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 or whatever your number is. 1515.
No way.
I see mine
It's
right
in there.
now.
Now, here's the weird part.
Where?
So, your cell phone number is in there perfectly. And here's the weirdest part. At some point, because mathematically it is possible, your birth date is right in front of it. And the worst part, your social security number, the number you're not supposed to hand out to anybody, is also in front of that at some point. Everyone's in the entire world. Because it doesn't repeat, it doesn't end. So mathematically, it is possible that it has everybody's combination of cell phone, birth date, and social security in order alphabetically. Because it will happen at some point.
So I can put a random number and call someone?
Yeah, it will happen at some point. Okay. Yeah, so it's weird. It's the weirdest thing in the world when you start wrapping your head like, it doesn't repeat, it doesn't end. So it has every possibility to have every combination of numbers in it at some point, including all the weird numbers. Now again, like I said, social security numbers, those are special. You're not supposed to give those out to anything, right? Because you only get one of those, and everything on your bank is attached to that number. So, and you can't get that replaced at some point. So that's one of those special numbers you never want to tell anybody. Only your employer should know that number because they have to pay
My
your
social
money to the
security
bank.
number?
Yeah. So you're not supposed to tell that to anybody.
What if one of your employers gave it out?
That's illegal. So there's major jail time. You probably get a pretty good lawsuit out of that.
Wait, so Mr. Haig has your social security number?
Yeah, has to.
He has to
Yeah,
just sit on
because
his
they're attached to my bank account when they pay me. Everything has to be part of it. So it's one of those things. Now, here's the thing. We've talked about all 5 categories. This category, even though it seems goofy,
Everybody.
it is the biggest category of them all. Because without all of these categories, you would not be able to draw the entire number line. I'll get to that here in a minute. I'll explain that. Is there any questions with the last two categories I just talked about?
No.
Okay, have your calculator out. We're gonna do one more little test here of like seeing if you know what categories numbers fit in where. Okay, so here we go. If you have your calculator out, this would be a good thing to have. All right, so I'm gonna give you a number on the board. I'll give you the answer here in a second on what category it fits into. Now, some of these could fit into multiple categories. So here we go. Here's the first one. Don't blur it out loud. Just sit and look at it. First number, 9.3. I want to know what classification. Let's talk about the classifications. You've got natural, whole, integers, rational, or irrational. What category does the number 9.3 land in? Well, let's think about that. The category it fits into one specific category, and only one. Not multiple, this only fits into one. Okay, what do we think? Somebody raise your hand.
Rational.
Rational, why?
They can have fractions.
It's a fraction or it's a decimal that ended. Do you agree that decimal ended?
Yeah.
It didn't repeat, right? It didn't have a little bar above it. That's a terminating decimal. That's a rational number. In fact, I can make that a fraction. That's 9 3/10. Because it only has one decimal point, just put a 10 on the bottom of it. So 9 3/10. Now, next category, or next number. -15. What category? Integers. It can also be a rational number. Because I can make that -15 over 1. It's a whole number, I can put it over 1. So that is an integer by its first category. Next category, 5/6. What category does 5/6 fit into?
Rational.
No.
Rational, because it's a fraction. If you can write it as a fraction, it's automatically rational. Last one here, 24.
Whole.
Whole, or
Natural.
or natural, or rational, or integer. We have a lot of categories. I would say the first category for 24, I would say natural.
Natural.
It's the first category you learned, right? It's natural. But I could see you could call it whole, you could call it a rational, because I can make that a fraction. 24 over 1. It's a whole
One
number.
test can give it to us if we did natural.
Yeah, take it too. Yep. So, okay, do we feel comfortable with the categories these fit into? Okay, that's gonna be your exit ticket today. We're gonna have about 5 of those.
Guard.
You guys ready?
Yep.
All right, I'm gonna put them on the board. Here we go.
Put it in your belly button.
So, take out a piece of paper, separate sheet of paper.
Have you seen it?
Yeah, I've seen this probably.
Okay, separate sheet of paper. You're gonna put your name on it. You are gonna turn this in. This is your exit ticket today.
It's so bad.
All right, here we go. I want to know what category these numbers fit into. You have 4 numbers I'd like you to put. Only 4. I'm not going to do 5. So here you go. Here's your example. So on your paper, have your name, and below it, numbers 1, 2, 3, and 4. Okay, you're going to write down the number I'm going to give you here in a second, and then tell me the answer the category it fits into. If it fits into multiple categories, tell me what categories it could fit in. I know you want to tell me the first one you can think of. Also tell me if it fits in any others. So here we go. First one. Don't say them out loud. First one's 2/7. The next one is the number 8. The next one is -12.7. And the last one is -3. So what I'd like you to do, tell me what classification it fits into. If it fits into multiple, tell me which ones you know. Okay? This is your exit ticket for the day.
Okay.
No, do all 4. So you're gonna write down number 1, tell me that one. Number 2, write that one. Write down those, put your name on it. You are turning this paper in before you leave in about 4 or 5 minutes.
You got a pencil marker.
Here.
So we can do more than one now?
What?
We do all of them? Not
Yeah.
two.
Yep. 1, 2, 3, and 4. So you gotta write down those numbers and tell me what classification you fit into. We're gonna turn this in right before you leave. I wanna see how well you were catching this today before we leave here. Over the weekend, I'm gonna enter your homework that you just turned in today or yesterday. I know some of you did turn in homework yesterday. Good. Yep, if you have not turned in today's homework, get that turned in, make sure your name's on it. Okay, remember, you're turning in this piece of paper with those 4 problems on it.
He's Walmart too.
Okay, there's your 4.
You guys got
So yeah, so I want you to write these down and then put the answer right next to what you think it is. That's what I want. Remember, you're gonna turn this in 2 minutes. So get it done.
Please.
Cheating.
Where do I put this?